All right, so here's one of our problems. Um, so it says a planet has a radius of 13,500 kilometers and the mass of um, 5.9 times 10 to the 25th kilograms. Find the escape velocity from the surface of the planet. All right, so since this is the radius, that'll lead us to the surface. All right, so the radius here, r, is equal to 13,500. Of course, that's kilometers. And in the equation, r right there has to be in meters. So we have to convert this. All right, so this is 1 kilometer is 10 to the third meters. That's supposed to be a 3. Sorry. All right. So this becomes 13,500. You could put 3 more zeros, or you could say times 10 to the third. That's supposed to be a 3. Sorry. Third meters. All right, so we're going to use that number in the escape velocity equation. Okay, so well, the other thing that I'm going to do that's slightly different from this, it says to find the escape velocity. So just as a reminder, let's go into everything here. All right, so we're gonna figure out v escape. All right, the mass. All right, so I'm gonna put this over here. All right, so the mass has to be in kilograms. Right. And of course, there it is, right? It's already in kilograms. We're good there. Big G, the universal gravitational constant, is always 6.67 times 10 to the minus 11th. And of course, it does have units, but as long as we keep, it's really if we have the mass in kilograms and the radius in meters, then we use this number, 6.67 times 10 to the minus 11th. The units come out correct. And then, of course, the velocity, the escape velocity is in meters per second. All right, so what I'm going to do is we're going to convert it. So once we do the calculations, we're going to convert it to kilometers per second. All right. A lot of times we'll do this. There's certain units that are more convenient in astronomy. All right, all right, so let's do this problem. Here we go. So this is equal to, so it's the square root of, so it's 2 times big G, and so big G, of course, is 6.67 times 10 to the minus 11th. I'm going to use the capital E minus 11th. That means the same thing. Times our mass, which is given to us as 5.3 times 10 to the 25th. Of course, it's kilograms. I'm going to just put the kilograms. Geez, that doesn't look like a K. So sorry. Yeah, it just does not look good at all. Sorry. Here, let me clean that up just a little bit. All right, there we go. All right, so this is times 10 to the times 10 to the fifth kilograms. It still doesn't look very good. All right, let's get rid of some more of this. That doesn't look good at all. All right, very good. So, and then we divide the whole thing by so that this number that we have gotten, 13,500, and then it's got to be in meters, so it's times 10 to the third meters. All right, so the mass is already in kilograms. It was given to us in kilograms. Remember, you sometimes you got to do these conversions. All right, so here's our calculator. All right, so I'm going to do what's underneath the radical first. So it's 2 times 6.67 times 10 and to the minus 11th, all right, times our mass, which is 5.3, 5.3 times 10 to the 25th, right, and then divided by our the radius, right? And but by the way, if you wanted to adjust it for some height above the radius, it would be the radius of the planet plus the height. All right, just to let you know, it's just another version of this. All right, so we hit divided by, and it's going to be divided by 13,500. And you could put 3 more zeros, or you could say times 10 to the third. All right, so this is not our answer. We still have to take the square root. All right, so we take the square root, and so the number that we get is, so I'll write this down. So it's 22,884. I'm going to round to one place past the decimal. Let's say it doesn't say that, but on test situations, it always says round to one place past the decimal or 2 places past the decimal. All right, so so this is remember, this is just some planet. All right, so this is equal to 22,884. Get the point. Where's my calculator? 84.89. So I rounded up to 0.9. 0.9. All right, and of course the answer comes out in meters per second. All right, to convert it, so we want to convert this to kilometers per second, and that's pretty easy to do. So I just say, all right, 1 kilometer is the equivalent of 1,000 meters, or 10 to the third meters, right? It's the same thing. The meters cancel, and so then we have kilometers divided by seconds, so kilometers per second. All right, so really all we have to do is divide this 22,884.9 by 1,000, and then we'll go round to one place past the decimal. So this becomes there's the decimal. We got to move it 3 places to the left. So 1, 2, 3. All right, and so this becomes 22. So 22, and it's so it's 0.88, so it's going to be 22.9 if we rounded it to one place past the decimal, kilometers per second. All right, so that's a very typical speed that we would use. Right, let's. I'm gonna do this problem slightly differently, since we already have these numbers here. If we just take away the square root of 2, not take it away, but we don't include it in the calculation, then this becomes what's called the orbital speed. All right, so I'm gonna work on that now. All right, so I rearranged this, or not rearranged it really. I just erased the 2, and so this is now what's called the orbital speed. And it's notice it's always going to be less than the escape velocity. The escape velocity would be, to leave a planet and never come here. Let me draw a little picture. All right, so the escape velocity is when you leave a planet and you never come back. The orbital velocity, so that would be v escape. All right, the orbital velocity would be the minimal speed to keep going around the planet. That's the orbital velocity. ORB sometimes is it's supposed to be an O right there. Sorry, it doesn't really look like one. All right, so here's the equation for the orbital speed. It looks a lot like the escape velocity equation. We're going to put the numbers in here, and we're going to get so remember we did it. It was 22,800 and something. Well, we're going to see it right here. So there it is in our calculator, 2,884.9. All right. We'll do the same kind of thing as we just did. We're going to solve it, and then we're going to convert it to kilometers per second. All right, so here we go. All right, so it is, we're going to do the same thing. What's under the radical, we're going to do first. So it's 6.67 times 10 to the minus 11th times 5.3. It's the same planet. We're doing the. I mean, this is a little unrealistic because this would be the orbital speed from right at this, right above the surface. Anyhow, times 5.3 times 10 to the 25th. Remember, that's the mass of the planet. Divided by. You know what? Let's do this. Let's say we added. I'm sorry. I'm going to calculate this first. All right, and then maybe we'll try to add 500 to this. Okay, so but right now we're just going to do it as it sits. So divided by 13,500 times 10 to the third, or put 3 more zeros. Either way, it's the same thing. Equals. All right, so then we take the square root. All right, so notice now it's 16,182. All right, so if I were to, 16,182, here, let me write that. 16,182, 16,182. And of course, that's meters per second. That's the orbital speed. But of course, it would be 16.1, right? So 16.1 here. If we, I'm sorry, it would be 16, sorry, I messed that up. It would be 16.2, right? Because the number after the 1 is an 8. So it would be 16.2 kilometers per second. Right? So, we just moved the decimal place 3 places to the left, right there. All right, and so we compare these two, right? This one is 16.2. The escape velocity is 22.9. The escape velocity is always greater than the orbital velocity. All right, so what if this object was So here, let's recalculate this. Here, let me pause. All right, so when we did it before, the orbital velocity at the surface of the planet was about 16.2 kilometers per second. So now what I'm going to do is I'm going to add, what if it was 1,500 meters above the surface? That's still that like on Earth, that would be cloud level. We'd really want to be higher than that, but you get the idea. All right, so here, let's do this calculation real quick. I'm gonna actually pause it. All right, so I put part of this. I put the numerator in the calculator so far. The 6.6 7 times 10 to the minus 9th times the mass of the planet. And now this time, instead of dividing by the radius of the planet, we're dividing by the radius plus that 1,500. Okay, so of course that would be let me this would be 1,500. So divided by 1,500. All right, so divided. Did I already hit divide? Yeah, I already hit divided by. So it would be 15. 15,000, right? 15,000. And then of course you have to account for the times 10. Oops. Let's see. You know what? I don't know that I did that right. Hold on. All right. So this was for 15, adding 1,500. I actually meant to add, put another 0 in there. Don't worry about it. All right. So I'm running out of time. And then I take the square root and see that this is not right. Hold on. I'm running out of time. But it's actually almost the same. I should have made the the height much higher, it would have been different.